The title of our chosen article is Alphabetic Time Series Representation with Trend-Based Approach, which is 4 pages long. The authors of this article are Kalyani S. Hatwar and Sagar S. Badai. The source of this article is taken from IEEE and it is published in March 2015. Before we move on to our article, let us first briefly explain both sequence and series. Sequence is a list of processes or numbers written in a definite order. A perfect example of how sequence is like in numerical form, we can look at Figure 1, and for an example as to how it works in processes, we can see the sequence of a caterpillar transforming into a butterfly, in Figure 2. As you can see from the two figures, sequence is a particular order in which related things follow each other. Sequence can also be either infinite, where we are looking at the sequence of odd numbers, or it can be finite, if you are looking at the sequence of evolution. We will now explain how series works. Series is composed of a sequence of terms that are added up, which can be either finite or infinite. An example is Figure 3, where x is the summation of the terms in the finite sequence. This explanation is rather vague, therefore we shall continue to use our example based on cooking an apple vinegar roast pork. In this video, you can see the relation between series and sequence. We can infer that the cooking is done sequentially, where each step has to be done in sequence. Whereas, in series context, cooking time would be the summation of the time taken for every step, which in this case is 44 minutes. Now, let us move on to our article. In our article, we were given this diagram, which shows us how series and sequence is done on a trend-based, data mining approach. We will use the food industry as our example to show how the diagram would relate in predicting the top-selling dish using alphabetic time series representation with trend-based approach. Step 1. Data collection is done on a particular restaurant. We will gather data based on their menu, dishes ordered, number of customers and customer satisfaction level. We will take the data for each day till the end of the year. We then get the summation of all the data gathered. Step 2. Finding trends. From the summation of the data for the year, we can derive different types of trends, for example, top sellers, seasonal period or order patterns. Step 3. Segmentation. From the trend analysis, we can further analyze by segmentating each trend. For example, the top seller could be segmented into 3 segments: breakfast, lunch and dinner. Each segment shows the data collected yearly. Step 4. Segment approximation. For each segment, we can deduce the ratio of the best and the worst dish for that period. We can then know how much resource to allocate or which dish to discontinue to save costs since it is not selling well. Step 5. Symbolic representation. We then take the best dish for all 3 segments and give them a symbolic representation. A will be the best dish for breakfast, B for lunch and C for dinner. A graph can then be plotted to compare each year's. Step 6. Prediction. Finally, after comparing the results in the year, we can then compare the summation of the best dishes, A, B and C, for all 4 years. Using the results, we can predict the most popular dish that can be promoted in the following year. This process of sequences shows a crucial part in deriving the prediction. In certain steps, sequences and series plays an important role. The steps must be followed sequentially to obtain the end product. The series is the summation of the time taken for each step. Done by Arathan Amar Sanger, Adam Tan, O Yun Sheng, Kua Chen Ek, Long Kai Yayu, Wang Sin Quan.